In this video, you are going to learn how insertion sort works under the hood. First, we will look at the working of insertion sort, then we dive into the code, and finally, we will look at some characteristics of insertion sort. So, without any further ado, let's jump straight into it. Insertion sort is a simple sorting algorithm that works similar to the way you sort the playing cards in your hands. The array is virtually split into two parts, a sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. Let's look at the working of the insertion sort in greater depth using an example. We have an array of 5 elements 8, 5, 9, 0 and 4. We have to sort the array in ascending order using insertion sort. In insertion sort, all the elements are traversed at least once. So, in the first iteration, the first two elements of the array are compared with one another. Here, 8 and 5 are not in ascending order. That is, they are not in their correct position. So, we swap 5 and 8. For now, 5 is sorted. In the second iteration, the next two elements are compared. Here, 9 is greater than 8, thus both elements seem to be in ascending order. So, no swapping would occur. For now, 5 and 8 are sorted. In the third iteration, we move forward to the next two elements, that is 9 and 0. Clearly, 9 is greater than 0. So, we swap 0 and 9. After swapping, we can see that 0 and 8 are not sorted. So, we swap 0 and 8. Again, we see 5 and 0 are not in correct order. So, we swap 0 and 5. For now, 0, 5 and 8 are in correct order. Moving to our last iteration, we compare the next two elements, that is 9 and 4. Clearly, both are not in ascending order. So, we swap 9 and 4. After swapping, 8 and 4 are not in order. So, we swap them. Again, 5 and 4 are not in order. So, we swap 5 and 4. And yes, finally, the array is sorted. This is how insertion sort works under the hood. Now, let's look at the code for insertion sort. We have a basic structure of a C file. We have implemented the header file. Then we implemented a print array function which prints the array. In the main function, we have declared an array to work with. Then we have a variable called n which contains the size of the array. After declaring all the variables, we call the print array function to print the array before the array is sorted. Then we call the insertion sort to sort the array, and finally again we call the print array function to print the array after the array is sorted. We implement the insertion sort. The insertion sort takes two arguments, array and the size of the array. In the insertion sort, we declare two variables, key and j. Key stores the ith element, that is the element to be placed in its position. J is the previous element of the ith. Then after declaring the variables, we call a for loop which runs from 1 to n over the array. The second element of the two comparison elements are selected, that is, I stores the second element of the two comparison elements. In the for loop, we update the key variable to the ith element. The ith element is stored, that is, the element to be placed in the correct position. Recall the theory behind it. After updating the key variable, we declare j is equal to I minus 1, the element previous to the ith element. We run a while loop which runs if j is greater than or equal to 0 and if ARR of j, that is the previous element of ith, is greater than the ith element. That is, if the previous element of I is greater than the ith element, then we swap them, that is, the ith element gets the previous element and we decrement j. The while loop stops if the current jth element is less than the ith element. So we swap the jth element's next element with the ith element. It's a bit confusing, so if you still do not understand, try to sort an array of your own on the paper using the insertion sort idea. Now let's look at the output. Here we input an array of elements which are not sorted, that is 8, 5, 9, 0. After sorting, the elements in the array are all sorted, that is in the form 0, 4, 5, 8 and 9. Yeah, this code works. By the way, the source code is in the description, so do check it out. The time complexity of insertion sort is big O of n square. Some characteristics of insertion sort is that it is one of the simplest sorting algorithms with simple implementation. Insertion sort is efficient with small data sets and insertion sort is adaptive. That is, it is appropriate for the data sets that are already sorted. Finally, if you are still here, you might be a student or a developer who is here for a solution or an hobbyist who likes the fascinating world of algorithms, just like me. If you are one of them, then consider subscribing. You would not regret. If you found value in this video, hit the like button, which definitely makes a huge difference. To test yourself, try to sort the array in descending order using insertion sort. If you succeed, then congratulations, you have mastered insertion sort. If you fail, do not worry, it is just a part of the journey. Rewatch the video, understand the idea behind the algorithm rather than code, and try it again. Finally, congratulations and signing out.